All right, can everyone hear me? Awesome. All right. Hi, everyone. My name is Adam Patni, and I'm a high school junior. This mentorship, I decided to work on a project for my FRC robotics team. I decided that I wanted to focus on the vision processing aspect of the competition. Every year, the competition releases new vision targets that are strategically placed above each mission. These targets have historically been geometric shapes, ranging from circles to squares to pentagons. Last year, the target was 2 rectangles with a peg in the middle. The goal was for the robot to place a gear on this peg and center in between those 2 rectangles, as you can see on the screen. Our team has never actually done vision processing before, so this summer I decided to build an application that could detect these rectangles and move the robots towards them. I used a Raspberry Pi as a co-processor and set up a server client system to send data between it and the robot. Using OpenCV, I was able to detect those rectangles and get certain dimensions from them, such as center coordinates and height and width. With that data, I set up a PID controller to center the robot around these coordinates. As you can see from the video, it's not super accurate and pretty jerky. So this mentorship, I decided I wanted to improve upon this system and make the detection and control system more accurate. And so as I press that button, the robot starts to move. And the first time it worked, however, the second time it didn't, and that was one thing I wanted to improve on. Awesome. So my main objectives during the program were to improve the speed of processing, improve the accuracy of target detection, increase the accuracy of my movements, as well as decreasing the latency in the project, in the network by processing a lot faster. So another thing I really wanted to work on was machine learning because it's kind of a buzzword, and I was really interested in learning a lot about it. So after discussing with my mentor, Nick, we came to a conclusion that without having access to my robot during the school year, it would be best to build a simulation of these targets. We would be able to simulate the robot's position in 3D space, as well as capture the picture that the camera would take of these targets. With this data, we could then extrapolate the angle of desired motion that the robot has to take. So I started off by writing code to create these rectangles in space and move them around randomly. From the rectangles, I collected a bunch of data, including the XY position of the 2D coordinates from the picture, 3-dimensional coordinates, so like the 3-dimensional coordinates in real space of the center of those targets, as well as the height and width, which all correlate to finding out the real position. And so with this data, I was actually able to train a linear regressor as well as a neural network using the sklearn libraries in Python. For those of you who don't know what a neural network is, basically it's a type of machine learning that uses a series of layers and weighted averages to determine the correlation between input layers and output layers. So the neural network actually ended up being a lot more accurate than the linear regression technique. And so somebody earlier was mentioning how they only had like 250 different points to test their data off of. My simulation created around 1 million points to test the data off of, and I used 500,000 to train the model, and then another 500,000 to actually test that model to determine the accuracy. And so that's how I determined that the neural network was a lot more accurate than the linear regressor. And so in order to make the model more robust, I actually added in some error to every single thing, so that every single input, so that I knew that when I put this on the competition robot, it would work better. Yeah, work better. And so here you can actually see a video of the data collection. So on the left over here, this is the simulation of data being collected. And so right now you can see what the robot would see. And so as the rectangles get smaller, basically that's simulating the target getting farther away. And as it moves left and right, that's like the robot moving left and right. And so I used a Jupyter notebook to parse through all this data and then train a model with it. To deal with the data, I actually ended up learning pandas, which I thought was really interesting to work with. And so here, I'll play it again really quick. On the right side, you can actually see the extrapolation of the angle of that the robot needs to travel in. Basically, this program on the right side pretends that it's the robot, and that all it can see are those two rectangles. And then using the neural network, it determines the angle of best fit to move the robot towards that center coordinate. And so right now, it kind of looks like the line is moving up. But if you imagine this in 3D space, basically what's happening is I have a point here and a point like over here. And when that's projected onto the screen, it kind of looks like it's going up and down. In order to visualize kind of in order to visualize the data that I collected from my simulation, I used matplotlib to kind of graph all of the data I collected. This is like a small subset of the data that I had. And basically what you can see is that you can see a correlation between the x values that are taken from the screen and the angle in degrees. And so that would be the top graph. And the bottom graph is the distance versus the angle. And so you can see that there's a wide range of angle values, which means that the algorithm does in fact work as I predicted. And so for the x values, basically as the robot moves side to side, you'll see that the angle is going to change more this way and this way. And so throughout this mentorship, I learned a lot of things. I worked with libraries like OpenCV for computer vision, OpenGL for my simulation, Pandas for data processing, and Matplotlib for data visualization. I also had a chance to use Jupyter Notebooks, which were really awesome for data science. I had never actually thought of using any of these resources without the help of my mentor, Nick. And so I'd also like to really thank Patrick, because he introduced me to the program. And with that, I'd like to take all of your questions. Thank you.
Take your microphone off.